Okay, so now we're getting to chapter 9, and we are going to talk about solutions. So the first thing we're going to do in this section is we're going to define solutions, and we're going to sort of look at carefully some important aspects of solutions, namely solutes and solvents. Okay, so solutions are homogeneous mixtures of two or more substances, and they form when there's sufficient attraction between a solute and a solvent. They have two components, at least two components. The solvent, which is the one that's got the more, and the solute, which is present as the less. Okay? So our learning goal here is first of all to describe the formation of a solution and then to identify the solute and the solvent in a solution. All right? So let's look at them more carefully. So first of all, it's important to appreciate, in my previous definition, I didn't say if solutions were liquids. I guess I personally think of solutions as liquids, right? I think of Kool-Aid or coffee or tea, right, when I think of solutions. However, solutes and solvents, actually, solutes can be liquid, a gas, or a solid, right? Solutes are spread evenly throughout the solution, okay, and they mix with the solvents so that the solute and the solvent have the same physical state. They cannot be separated by filtration, but they can be separated by evaporation, and they're not visible, but they can make a color in the solution, right? Like coffee, right? Coffee, the solvent is water, and the solute is lots of different things that make coffee dark. All right, so let's look at a specific example of a solute. If you take copper sulfate, all right, and you dissolve it in water, copper sulfate you might imagine to be little gray spheres and little blue spheres, right? But once it gets dissolved in the water, and can you see what's going on here with this picture? There's a bunch of water here, and there's your copper sulfate, okay? And then after it gets a chance to dissolve, it all breaks up, and the solute particles, that is the copper and the sulfate, break up, right? And they are spread evenly throughout the solution. Okay, so some examples of solutions are here. There's some kind of cool ones. A gas solution might be air, right? Where air it's mostly nitrogen, but it has a little bit of oxygen in it, enough for us to breathe, right? You know, air is mostly nitrogen, and it mostly doesn't do anything. It just goes into our lungs and comes out of our lungs. All right, so those are gas solutions. Liquid solutions, we might have a liquid in a gas, a gas in a liquid, right? So carbon dioxide, for example, might be dissolved in water. Carbon dioxide might be dissolved in water. Or another gas that can be dissolved in liquid is household ammonia. So we might have ammonia dissolved in water, and we use that to clean our windshields and our mirrors, glass, and other things too, I guess. So we could also have a solution that is a liquid dissolved in a liquid, where we have acetic acid, which is a liquid, and water, which is a liquid. So those two liquids mixed together. All right, another example of a liquid solvent, but with a solid dissolved in it, could be, say, seawater, where you have salt, which is a solid, dissolved in the water. Okay, or tincture of iodine, which I think is less, I've never seen it or heard of it, but you might have ethanol, which is like alcohol, and iodine dissolved in it, where iodine is a solid dissolved in the ethanol. Okay, you can also have solid-solid solutions. This is a little difficult to imagine, but a brass, for example, is a solid-solid solution where you have zinc dissolved in copper sulfate, or steel, which is copper dissolved in iron. All right, so there's some examples of solutions. Now let's consider a really important solution or a solvent, which is water, and lots of solutions that we make with water. Water is by far and away the most important solvent in nature. Very, very common in nature. And it's a great solvent because, first of all, it's plentiful, but secondly, because it's made up of polar molecules, and they're polar because they have the OH bond. So you saw this a few chapters ago. This is a little picture. Can you see the OH right there? It's my water molecule right there, where the red sphere represents the oxygen atom, and the whites are the hydrogen atoms. And remember, the oxygen is electronegative. And since the oxygen is electronegative, then it's going to have a partial minus charge on it, and it's going to take away electrons from the hydrogen, so it's going to leave a partial positive over here, and those partial minus and partial positive are going to be attracted to each other, right? So that's called a hydrogen bond, by the way, right? Remember that? Hydrogen bonds where you've got an electronegative element bonded, sort of associating with a hydrogen on a different molecule. Okay? So water is an excellent solvent, and it makes hydrogen bonds with many important biological compounds, many important biological compounds. So appreciate a moment to talk about the formation of solutions. The formation of solutions, they form when the solute-solvent interactions are strong enough to overcome the solute-solute interactions, right? So a solute-solute is basically like two salt particles just hanging out together, right? And they're not going to be dissolved in water until the salt water, right? There's the salt right there, and there's the water. When those interactions become important enough, then it dissolves. All right. So when the solute-solute interactions are overcome by the solute-solvent, and when the solvent-solvent interactions are overcome as well, although those are not as important. Okay, solutions will form when the solute and the solvent have similar polarities. And we use the term like, or the phrase like dissolves like. It's an adage, I guess. Like dissolves like, right? So you might, if you have a polar solute and a polar solvent, it'll work. If you have a nonpolar solute and a nonpolar solvent, it'll work. It will form, okay? But if you have a polar solute and a nonpolar solvent, you will not get a solution, right? And some examples in the previous slide, I just sort of glazed right over them, right? But here's some examples on this slide. You might have, I haven't said what these are, but if this could be water, and this could be iodine, right? And iodine is nonpolar because it's just two atoms bonded to each other. And water is polar, and so we have a nonpolar, supposedly a nonpolar solvent, or rather solute down here, right? And it's not dissolving with the water up here. Okay, and some other examples, which we won't get into right now. All right, so let's talk about the solutions with ionic solutes. So if you have salt, for example, salt, sodium chloride, that's ionic, right? It breaks up into sodium plus and chloride minus. Well, if you add water to this, which is what this little thing right down here means, if you add water to this, then the water molecules say, look at this, see the water molecules surrounding that the sodium particle? They're like, no problem, I've got charge here for you, right? The oxygens have a partial minus on them. Remember that? The oxygens have a partial minus, which is not showing right here in this slide, but we showed it in a previous slide. And that partial minus surrounds the sodium plus, okay? Likewise, over here, the hydrogens, which have partial positives, can you see how they're associating with the minus of the chlorine ion? Chloride, I should say, chloride ion, okay? So solutions with polar solutes, here's some examples of that. You might take you might have a methanol, right? Which, here's a picture of a methanol. So there's an oxygen right there and a hydrogen. Can you see them? The red sphere and the white sphere. An oxygen and a hydrogen, which makes that, right? You still have the capacity for a polar bond there. And since it's got a polar bond, then methanol is polar, okay? And so if you take methanol, which is a polar solute, and you put it with water, which is a polar solvent, right? Then you get nice mixing. It's no problem. We like it. So there's your methanol molecule here. Here's your water molecule. And they're having no problems interacting with each other because they're both polar, right? Now, solutions with nonpolar solutes, here's some examples of that. Iodine, which is just I2, so you can imagine that that's not polar because there's no polar bonds in I2, right? What about oil? I don't show you the bonds of oil, but I'll tell you that oil or grease are not soluble in water because they're nonpolar, right? So you can have, so if you're going to dissolve iodine, oil, or grease, you're going to have to require a nonpolar solvent, all right, in order to get a solution to form. So let's practice this. Let's do, turn off the or pause the video and make a guess at this question. Identify the solute in each of the following solutions. Which is the solute? Remember, the solute is lower in amount, and the solvent is higher in amount. Okay, so identify the solute in each of these solutions. Pause the video and come back to it. Okay, so I'm going to suppose that you did pause the video. I'm looking for the solute, and I've got 100 mils and 2 grams, so that is clearly the smaller amount, right? Because remember, grams is 1 gram per, water is 1 gram per mil. That's 100 grams, essentially, of water. So there's way less sugar, and that is going to be the solute. What about 60 mils of ethyl alcohol and 30 mils of methyl alcohol? Well, that's clearly the smaller of the two, right? So methyl alcohol will be the solute. Okay. What about 1.5 grams in 55 mils of water? And that is the smaller amount. So sodium chloride is going to be the solute. All right. What about air? Air, if we have 8, this is pretty close to the right ratio in air. 800 mils of, oops, I circled the wrong one. If we're looking for the solute, we would go with the lesser of the two, and 200 mils of air is clearly less. So that is the solute, and nitrogen is the solvent. All right, so another learning check. Pause the video, have a look at this. Look it up if you like. This is a good one. Okay, so I'm going to suppose you paused it. Let's look at it together. When solid lithium chloride is added to water, it dissolves because what? Well, you've got the lithium ions, which are plus. They're going to be attracted to the partial minus of the oxygen atom, right? And the chloride ion, which is minus, is going to be attracted to the partial positive of the hydrogen atom. Okay? All right, and the final learning check. Pause the video and have a look at this. Which of the following solutes will dissolve in water, and why? Okay, I'm going to suppose that you paused it. Remember, water is polar, right? Because you've got the 2 polar bonds here, and the electrons are being drawn toward the oxygen, so you have a partial minus up here, and a partial positive over here, and a partial positive here. So plus sign there. And so it's going to require polar solutes, right? And sodium is an Na2, rather it's an A plus, and sulfate is SO4 2 minus. There's 2 sodiums because of this. It's got only plus 1. SO4 is 2 minus. This is polar because it's ionic, right? So this is definitely going to dissolve in water. What about gasoline? So again, you're reminded that gasoline here is non-polar, so it is not going to dissolve in water because water is polar. What about iodine? Iodine's not polar because there's no polar bonds in it, right? So it's not going to dissolve in water. But HCl, it will dissolve in water because the HCl bond is a polar bond. HCl, hydrochloric acid, is polar. Okay, so we have just now introduced ourselves to our solutions, and we've looked at solutes and solvents, what makes them, and how they're formed.